Hey guys, welcome to Project Pro. We're going to do ML Ops. This is very important that you guys learn this if you guys are going into data science and you're going to be a data scientist, machine learning engineer, because pipelines are what automates the ML lifecycle process. What we're going to cover also is model drift and why you need ML pipelines. Because if you just deploy a model, without CI/CD and manually retrain and hyperparameter tune, your model will have model drift very quickly. And we're going to cover the steps about model approval all the way from pre-processing to training and model registry. Okay, guys, let's get started. Okay, so we're going to use this data set. And as you can see, this is the test file. The target class is all nulls. That's because they haven't been predicted, this outcome. Okay, so you're going to download this data set, unzip it, and then we're going to unzip it right here, like I told you. Or you can unzip it and then import them separately. We're going to read it with pandas. Now, I do recommend, if you guys are watching my video, you guys at least know some ML ops and at least know machine learning fully, so you won't be learning too much and this won't be too difficult. Okay, then we're going to do some encoding. Copy this code as you see it. Okay, fill in A's for 0. And then that target class for the test data, remember that's no outcome. Well, you got to drop it anyways. So, and then read it. Okay, encode and then save them to CSV. Okay, guys, let's get started. Let's go to the notebook. Let's get started. Okay, guys, here's the Pulsar Star data set. Okay, we're going to create our default bucket model group name, and then we're going to do our pipeline session. Our local path is going to be the data frame. Okay. Your model approval status, like we talked about, because it has to be approved depending on the accuracy. And after you guys copy my code, you guys will see it'll be 92% accuracy. It has to be at least 80% for classification to be approved, if not more. For regression, 70%. Okay, there's our pre-processing file. So as you can see, we created a directory called marker, and we're going to IAM write it in Python. We're going to drop target class, and then we're going to PD concat, okay? The argparse function in our Python file. Okay. Sorry, it's just a lot of code. Okay, to CSV, input the new data, the new DF CSV. Okay. Our base job name it whatever you want, and it's going to appear on there. Okay. Pre-processing file. Now, as you guys know, Sagemaker is a CI/CD framework. Okay, and then our objective for the algorithm is going to be binary logistic. Do these right here, these parameters right here. Okay, and then our default bucket for the model path. Okay. And fit the data. Training step. Okay, and then our evaluation PY, because remember we have to evaluate the model to see if it's accurate enough for production. Here we go. Our classification report. Predict X test after the test train split. Score it. Predictions round them. And AUC is a tough metric. That's what we're going to use to evaluate it. And it scored 92%. The script processor. the evaluation report, and our processing step. And here's where we register the model, depending on the condition of approval. You guys see? Because if you guys notice the steps, pre-processing, all the way to train, to evaluate, and then the condition on approval to register. We're going to cover deployment in a bit. Okay. And then there's the path, binary classification metrics accuracy value, the JSON path. Name our pipeline at this instance. And then that's how you start it. This is how you can describe it. Okay. This is where you start it right here. List the steps. Now let's go to the model package. Okay, because it's when it's approved, you go to the model package. There's your pipeline, as you can see. Let's go to the... Okay, copy and paste that right here. Right here. And then we're going to make our first prediction on the test data. Import all these. And then this is how you actually have to do this when invoking the endpoint. And then we have to MP round the predictions. There they are. And here's our model default monitor, because we have to monitor it for model drift. We have to do a pre-processing job. Okay, as you can see. Okay. And then we have to have our monitor scheduled name, and we have to create the monitoring schedule every hourly. There's our baseline constraints. Okay. And then as you guys can see, this is where we can do quite a bit of things. There's your endpoints, as you can see. And then let me show you a little bit around Sagemaker Studio. This is where you can pull up all those things right here. Model Registry. As you can see, I've done quite a bit of them. Here's the Pulsar Star. This is model version 2. Now, one thing I wanted to talk about with you guys is how important this is, because a lot of data scientists end up doing machine learning engineer roles. They just call them data scientists. And this is the necessary needs for all businesses when doing it because of the heavy use. Remember, I told you guys how there's model drift because of so many predictions? Well, you're not done here. Once it's deployed and you're invoking predictions, you're also going to need to retrain the model on new data, hypertune the parameters as well, and continue the ML lifecycle. That's why they call it ML ops. Of course, as you can see, this never ends. It's continuous integration and deployment. I hope you guys learned from my video. Stay tuned. Next time, we're going to do a convolutional neural network. Take care.